Good morning. Good evening, Professor Chen.
Good,
So
good morning. Yeah, good morning.
yes. So this week we have a professor from our department, mechanical engineering, Professor Wei-Chen, who is going to give the presentation in the field of smart manufacturing. So he's actually, I don't know what's the Chinese, what's the English, 戒掉. What is the English of on leave. So yeah, so so sometimes professors can do some service outside on leave for I don't know extra money.
Without school's pay.
Yes. So I know many professors go to the industry. Some of the professors go to governmental service. So Professor Lee now is serving in a company called Force. It's a company that is working on smart manufacturing. So I believe he will talk more about his company and also the products they have made. And I just discussed with Professor Lee, and he mentioned you are welcome to visit their company on your trip. So I will tell you more about the field trip afterward. So I will give the time to Professor Lee.
Great, great. Thank you.
Thank you. Yeah. Uh, as you can see, we have a real-time caption over here. This is a function for Office 365. But this function is not included in the educational 365. So, okay, anyway. Good morning, everybody. Today I'm going to talk about implementation of smart manufacturing. Smart manufacturing is a fascinating term. It's also a fascinating business. That's the reason why I devoted myself into this business. Let me quickly go through my resume. Okay, I'm teaching in this university for. I'm teaching, but I've been teaching in the university for more than 20 years. But since August this year, I started to work for a company called SimForce. SimForce is a smart manufacturing company. SimForce exists in this business for more than 10 years. I have been conducting research in this field for many years. So when SimForce invited me to work for them, I simply agree with them and go work for them. Okay. And my research topics includes smart manufacturing, cyber security, etc. And the picture shows a cable climbing robot. Okay, that's our recent research results. We use that robot to climb to the cables on the Dachi Bridge. Okay, so it was a successful realization of the mobile robot used to inspect the cables on the bridge. Okay, but let's go back to the smart manufacturing. Many people may have different understanding or different definition for smart manufacturing. Okay, smart manufacturing is also there's another term called Industry 4.0. I think both may carry the same meaning. Several years ago, when Industry 4.0 came out, okay, when this kind of idea came out, I met a German, and he mentioned to me a lot of people invited him to talk about Industry 4.0, but actually he didn't know quite well about Industry 4.0. And there are many, many different definitions for Industry 4.0 or smart manufacturing. Okay, like the picture shows here is the power consumption monitoring in our Industry 4.0 Center at NTUST at our school. Okay, we use a SCADA software called Web Access to monitor the power usage for all the air conditionings in Industry 4.0. Okay, in the Industry 4.0 Center in the location. Okay, so this is the actual structure for our Industry 4.0 center, and we put a lot of sensors in the building, okay, so that we can monitor the power usage for air conditioning. And this is what we call SCADA. We use SCADA software to do that. I believe this is related to smart manufacturing, but in my definition, smart manufacturing is more than that. Okay. So another picture shows the monitoring of our machine tools. There are two machine tools in the Industry 4.0 Center. One is the top one, the other is the bottom one, and we also can access its power usage through the controller of the machine. Okay, so that's another way we monitor the machine's status. Okay. What is smart manufacturing? Broadly speaking, any method that simplifies the processes from design to manufacturing includes simplify the process, increase power efficiency, reduce manufacturing time, and lowers production cost. Okay, from my definition is smart manufacturing. Okay. To realize smart manufacturing is not to make a show or make a demonstration to people, to show the technology capability. For industry, the real goal is to save money or save time. Okay, so any method that can help our industry to save money or save time, in my definition, is smart manufacturing. Okay. My previous boss at Foxconn said that what is high tech? High tech is the tech that can help him to make money. I think same thing to me here is smart manufacturing that can help an industry to save time, save cost. Okay, that can be included in some way of smart manufacturing in broad view. Okay, in broad view. Some people always show the production automation, okay, but production automation exists in industry for many years, okay. Like if you can see people make some parts, okay, automatically, okay, or like TSMC manufacture the semiconductor, the ICs. Okay, TSMC has existed in industry for 30 or 40 years. Okay, for that kind of thing, production automation, I believe, is part of smart manufacturing, but it's not all. Okay, smart manufacturing is more than that. To me, production automation is to replacing operators. Okay, but smart manufacturing is to replace part of the engineer's job. Okay, in an industry, in our mechanical engineering, mechanical engineers need to do a lot of things. Like he needs to use CAD, computer-aided drawing, computer-aided design software to design the product, okay, and the manufacturing engineer needs to use CAM, computer-aided manufacturing software, to schedule the cutting path, okay, or to do the manufacturing planning. Okay, if we can reduce part of their work and allow engineers to do more creative jobs, I think that will fit in a narrow definition of smart manufacturing. Okay. So in a narrow sense, smart manufacturing uses digitalization and ICT technology, information communication technology, to simplify the process from design to manufacturing. Okay. And data generated upstream. Upstream means that when you design a part, okay, the CAD model can be used for manufacturing without the need to regenerate the model for manufacturing, which means that you can use the same model at many, many different places. Okay, by doing that, can save a tremendous amount of time and cost. So when data generated upstream during the design phase, then the data will flow downstream through the network. Okay, and then the data can be used for downstream process like manufacturing, testing, procurement, scheduling, etc., without the need for regeneration. Okay, so that can save a lot of work. Okay, how to achieve that? Okay, that's the main topic that I'm going to talk about today, how to implement smart manufacturing. Okay, of course, smart manufacturing is a very complicated process. Okay, so it involves a lot of technology, techniques, knowledges. So I cannot cover everything today, but I will show you a couple of examples to allow you to understand how people are working in this business by using certain techniques. Okay. So when people are talking about smart manufacturing, or when people are trying to implement smart manufacturing, you need to know what kind of industry you are going to work with. Okay. Because different industry may have different characteristic in their manufacturing or design process. So maybe 30 or 40% technology is common, but the rest of the technology may be quite different. So we need to understand what kind of industry you are working with. For the company I'm working with, our target industry is mold manufacturing and metal cutting. Okay, mold is equipment that can be used to mass produce plastic parts. Okay, but to build a mold, there are hundreds of components in a mold, and each component may be different. So to build a mold involves a lot of processes, manufacturing techniques, scheduling, and planning, all kinds of things. So it's a very complicated product to be produced. Same thing as metal cutting. And there are some other industry that you may want to apply smart manufacturing tools. For example, like assembly or component making. Okay, assembly like to assemble an iPhone. Okay, component maybe you want to make a switch. Okay, make a connector, something like that. That's component making. Okay, or semiconductor fabrication or automobile making. Okay, that's a target industry. And to implement smart manufacturing, you need to have a goal. What kind of goal you want to build? For example, if you own a factory, okay, if you want to apply some application to your factory, what's your goal? Is your goal just simply want to monitor your machines? Just like the first slide I just showed you, to monitor the power usage in the factory? Okay, if that's your goal, then it's basically Internet of Things. You can simply use some application software like SCADA software I just mentioned to realize the monitoring of the machines. But if you want to do more, for example, if you want to do unmanned mass production, okay, unmanned mass production means that in your production line, there's no operator, no engineer, okay, simply machines, then that's a different story, okay? But for unmanned environment, there are still different situations. One is to mass produce the same product. For example, if you want to make this microphone, 10,000 pieces a day, then that's called mass production. Mass production is somehow easier because you can adjust everything to fit the production to produce a single product. Okay, then you can remove all the operator and engineer, allow the machine to do the automatic jobs. Okay. But the most difficult thing is to do this unmanned one-off production. One-off production means you build each piece of the product you build is different. Okay, so if you want to build 1,000 pieces, different product, it's called one-off production. Okay, you are not mass produce the same parts 10,000 times. You are build one particular part, one by one by one by one. Okay, so you cannot pre-adjust the machine. Okay, you have to have sensors to detect the characteristic of the part you want to build. And your system should be able to upload any information or any program associated with that particular part. Okay, so that you can produce a single part just one time. Then next time another single product came out, you upload all the information, all the program associated with that particular part again, then you produce that part. So this is called unmanned one-off production. This is far more difficult than the unmanned mass production and machine monitoring. Okay, and this is unmanned one-off production is the goal of my company. Okay, so we are working on the unmanned one-off production for the mold manufacturing and metal cutting industry. Okay. To realize the unmanned one-off production, actually, let me show you the picture again. You got to have a hardware, okay? Then you got to have the software. The software side produce the necessary programs and the information to the hardware side, so the hardware side can produce the parts, okay, without operators, without engineers. Okay, so how to do that? There's a term called system integration. Okay, system integration is to integrate hardware and software, okay, and connect them together by using network. Okay. So in a smart manufacturing facility, you are going to see a lot of data communication between the hardware side and software side. Okay, and if the company's network, okay, if the company's network connected to the internet, okay, then another thing that you need to be careful is the cybersecurity. It's a security issue, okay, because the data coming back and forth, if some virus come into your company and go to your manufacturing facilities, then that may create problem. That may stop your production. Okay, if your production is stopped, then I think a lot of bad things will happen. So for a smart manufacturing company, actually, a special term is called system integration, or SI. Okay, so if later on when you are looking for a job, if you see a job, if you see a company say the company is a SI company, then that means is a system integration company. A system integration company may integrate software only. A system integration company may integrate hardware only. Okay, but my company integrate both sides, both hardware and software. Okay, and usually, as I mentioned, because it involves a lot of data traffic between machines, computers, servers, etc. So we need to protect the data. So we also need to integrate the cybersecurity into our whole system. Okay. For metal cutting or mold manufacturing, the hardware integration includes all different kinds of machines. For example, like machine tools. Machine tools means CNC machining center, lathe, EDM, electrical discharge machines, or wire EDM, etc. Okay. And for measurement, metrology, we have to integrate coordinate measuring systems. So when the parts, when we finish manufacturing the parts, okay, the parts can be moved to this machine for dimension measurement. Okay. And when we finish manufacturing the parts, we also, after measuring, we also need to move it to a storage, okay, storage system, okay, to keep the parts and take the raw material out of this storage for manufacturing another piece. So we also need to integrate this. And to take the parts out of the machine, because we are talking about unmanned production, so there's no operator. We need to rely on robots, industry robots, to take the parts out of the machine. Sometimes we also need to change the tools, the cutters for the machining centers. That will also depend on the industry robots. Okay, the industry robot need to take the tools into our machining center. Okay, take the unused tools out and put the necessary tools into the machining center, so that the component can be manufactured. Okay. And so we need industry robot. We also need autonomous mobile robot, AMRs, to move everything back and forth. Okay, so a lot of systems, hardware systems, get involved in this manufacturing, smart manufacturing. But actually, when we communicate with these machines, the real thing we are communicating is their controllers. Okay, the industry robot usually carry a control box, and the control box is a thing that we want to communicate with. Okay, so we have to connect the control box of an industry robot, okay, to the network, and through the network to our computers, so our computers can communicate with the industry robots. Same thing applies to every other machines. Okay. So in our computer or in our server, what kind of software we can use to communicate with this hardware? If you simply want to monitor your system, you can have the supervisory control and data acquisition software. Okay. And if you want to control your machines, there's a software application called Equipment Control System, ECS. Okay. If you want to control everything in your production line, you have to install or develop a software called Manufacturing Execution System. Okay. For even large range, okay, there's a Manufacturing Operational Management System. Okay. This system includes everything in your manufacturing environment. And I don't know if you have ever heard of a term called ERP. In every single company, they use the ERP system to control their resources, including human cost, finance, etc. Okay, and we can connect the MOM system to an ERP system, so both sides can communicate. So this is more than the manufacturing side, and ERP system is to manage every other aspect in your company. And all the data will be saved in a database. Okay, so that will also be integrated. And we also need to consider the servers infrastructure that we want to save our data. So there's a special structure called hyper-converged infrastructure. Okay. This structure allows your computer, usually this kind of structure is to integrate 3 different servers together. And there are, for example, like 20 application software run in this, in the 3 servers. If one server fail, then the other server can still work. Your application software can still work. So you can take this time to fix the failed server. So that's what we call hyper-converged infrastructure. And finally, we have to consider the cybersecurity issue. Okay, so for example, the basic cyber security protection equipment is called firewall. Okay, a firewall is we call a packet filter. Okay, in our network, all the data are sent in packets. Okay, and we need to inspect the packets to see if it's malicious or it's non-malicious. And the equipment that we can use to check the packets is called firewall. We can have firewall in our network. Okay, we have a lot of different tools, and we can use some rules to help us to protect our system. Okay. All the things need to be integrated to realize a manned one-off production. Okay. When I really get into this business, I found system integration is not to integrate system. It's not to integrate all this system. It's to integrate the people who knows this system. Okay, so I put the engineering team over here. System integration is actually team integration, to integrate people knows this system. Otherwise, you cannot realize smart manufacturing facility. Okay, and one more thing I didn't put on the slide is when people adopt smart manufacturing in their facility, they are, because this is a main one-off production, so they expect that the production line can manufacture parts 24 hours a day, 7 days a week. Okay. In other words, the production line cannot be stopped. If the production line stops, the boss in the facility will call us immediately. So we need to resolve the issue, okay, most likely remotely and immediately. So that's a challenge for smart manufacturing. Okay. And how to communicate with machines. One way to communicate with machines is to use API. Okay. API is called Application Programming Interface. If you haven't heard of this term, I think this is a good opportunity for you to learn this. And I will also suggest you that after the course, you can do some self-study for this API, because this is a very common technique that you use to you write a program to communicate with another program. Okay, the way it's called API, Application Programming Interface. And how to use API to communicate with a machine tool. Okay, there are several steps, but before I show you the steps, I show you an example. Okay. in our Industry 4.0 center, we have a machining center. The machining center uses Siemens A40D controller. Okay, and Siemens controllers have pre-installed OPCUA server. Okay, OPCUA is a communication protocol. Okay, if you don't know what OPCUA is, it doesn't matter. You can treat it OPCUA like a English or German or French, something like that. Okay. How to communicate with a controller who speaks German? Okay, you have to speak German too. And in a controller, there's an OPCUA server. So in your computer, you can build an OPCUA client. The client can communicate with OPCUA server. Okay. And you can write a program like this to communicate with the controller in a machining center. Okay. For example, you can claim yourself as a client. Okay. You can connect to the server by using a command like this. Okay. Then after you connect to the machine, okay, then this is an OPCUA grammar. It says namespace equals 2, S is machine status, which means that you want to get the machine status out of the OPCUA server, which is A40D controller. So you set up the variable here, and you send the request to the Siemens controller to ask the Siemens controller to provide you the machine's status. And finally, you can print out the machine status on your computer screen so that you can see the machine status from your home computer. But actually, the machine is in our Industry 4.0 center. Okay, so that's the way we communicate with the machines. So how to use API to communicate with a machine tool, understand the API's capability, of course, what kind of command you can send to the machine, and set up an environment. And you have to establish a connection. Okay, otherwise you cannot access the machine status and send the commands, retrieve the data. And sometimes if you have error, like if your connection is broken, okay, then there will be error message. Then you have to know how to deal with the error message. That happens a lot in real industry. Okay, so during the weekend, I usually don't like to look at my cell phones, because sometimes if one of our customers have problems, then we will see the problem and we need to fix that. Okay. The real smart manufacturing actually involves a lot of technology. For example, if you want to make a plastic component, like the shell of a mobile phone, of course, you probably have not seen this, but 20 years ago when we purchased a mobile phone, it looks like this, and we can change a shell, plastic shell. Okay, and for the plastic part, there are all kinds of manufacturing processes involved in that. Okay, if we want to reduce the process time, okay, from the design side or from the manufacturing side, a lot of things can be done. Okay, but due to the time limited, I'm not going to go to the details. But you can see that if we want to make a part, I have to design a mold, okay, and to manufacture a mold, sometimes I need to first build electrodes and use the electrodes to build the mold part. Okay, and when I design the electrode, I need to go to the CAM, computer-aided manufacturing, to produce the cutting tool, okay, to cut the electrode. Okay. And when I need to cut the electrode, I need to do simulation because sometimes the machine tool, the tool may collide with the machine itself. So I need to do the collision analysis. Okay, then I can go to, if everything is okay, I can start making my mold. Okay, then I can do the component manufacturing, and component manufacturing means that I produce the plastic part. Then after I produce the plastic part, I can do the testing or dimension check. Okay, and if you want to do the dimension check, you usually use a CMM, coordinate measuring machines to measure the dimension of the plastic part. And if you want to use the machine, CMM, it requires programs. So you also need programs to control the CMMs. Okay? And that program can be automatically generated if you can write programs. Okay. So let me skip this. And this is the whole modules for SimForce smart manufacturing applications, which includes task management to control the task in each stage of the manufacturing. And we have database, we have MOM, okay, we have the operation production line, the hardware side, okay, we have APS, advanced planning and scheduling. For example, if I want to make 1,000 pieces of parts, okay, which one should be manufactured first and which one should be manufactured last? We have to have scheduling for that. That's controlled by the APS, and we have ECS, equipment control system. And we need to integrate all the hardware, the CAD software, HCI, hyper-converged infrastructure, and we also need to integrate various CAM software because we have many customers. Different customers use different CAM system. Okay, so our system can fit all the needs for our customers. Okay. So I will skip this. And this is a CMM I just mentioned. Okay. If we want to use CMM, we need to have a program to be able to allow the machines to do the inspection, to measure the dimension of our parts. Okay. And that program can be produced automatically. And the way we use is what we call feature recognition. Okay. So this is the basic idea. We have a 3D CAD model. We can do automatic dimension. You can set up for inspection and planning, generate inspection path automatically. Okay. Then we have a path verification to verify that when we measure the parts, there is no collision. Okay, because sometimes the probe may collide with the component. Okay, then that's not what we want to happen. Okay, then finally we can generate the code and send to the machine to allow it to do a real inspection. Okay, so we can import the CAD model into our system. So this is what I mentioned. We don't need to regenerate the component. When the component is designed in our CAD system, that can be imported from a CAD. Okay, and because we want to do the simulation, we also need to import the CMM model, the machine's model. Okay, then we write a program to identify the feature of the component, like the top surface, the pocket over here. Okay, then based on the program, we can generate the inspection path. Basically, the probe of the CMM will follow this path to do the inspection. And finally, it will generate the program. This is the program that will be sent to the CMM for operating the real machine. Okay. So let me show you the video. Okay. Okay. I'm sorry for some Chinese. Okay. Basically, we use feature recognition to find the features from this component. Okay, then after we find the feature, we can do the automatic dimension and output the engineering drawing, because sometimes people still like the 2D drawing. Okay, then we start to plan the measuring path, and we have to select what kind of CMM we want to use, what kind of probe, and we can start to do the simulation. Okay, to make sure that everything is okay, then we will go to the real machine to do the inspection. Okay. Then finally, we output the code for the machines. And this is the code we send to the computer of the CMM machine. Okay. And this is a case study. This is a real part. This is it's a CAD model. So we use face recognition to find all the holes on the top side and bottom side. It took about 44 seconds to do that. And there are 100 features, so we need to generate 100 inspection paths for those features. And this is path planning's results. And if we do that by manual operation, it may take 45 minutes for the top side and 44 minutes for the bottom side. But if we write a program to use feature recognition to automatically generate the tool path, the inspection paths, it only took us about 2 minutes something to finish everything. So you can see a lot of time savings over there. Okay. So let me summarize what I talk about today. First, smart manufacturing. It's a technology that depends on the ICT technology, software technology, and that can help us to automate or improve the current product development process. And one way to help us to achieve smart manufacturing is to use APIs, application programming interface, to help us to communicate with all the machines, controllers, etc. Okay. And finally, I would like to emphasize again, real system integration is extremely complicated. When we talk about one-off production, 24 hours a day, 7 days a week, okay. So it involves too many techniques and details. So that's pretty much what I would like to say today. Thank you very much.
Okay, thank you. Any questions from Professor Chen or from the student?
Yeah, I do have one question actually, Professor Lee. So thanks for the talk regarding to smart manufacturing. Actually, yeah, I'm also very interested in smart manufacturing. So you have a lot of insight from the real company case, I guess. But one question I have is for academia in university, are there any research that's key bottleneck that's facing by company, something that academia can do to contribute to this smart manufacturing research? Maybe you can share some, something you think are pretty challenge, something that need academia with a lot of actually efforts that need to be addressed. Maybe you can share one or two thoughts regarding to that.
Okay. First of all, I'm not a software guy, so there are a lot of software that get involved in this smart manufacturing. But there are still hardware part for the smart manufacturing. So currently, I'm helping the company with cybersecurity part because I studied the cybersecurity, operational technology cybersecurity for a couple of years. So I'm familiar with this part. And I'm also helping the company with the autonomous mobile robot. I didn't show you the video, but when we build this, when we realize our production line, we also need to have the hardware that can help the company to realize the continuous production. Okay. And we are working on this AMR. This AMR actually carries the thing may be as heavy as 1,000 kilograms. Okay, so this is a very heavy stuff, and we need to make sure that every time it carries the thing, it works. Okay, if it failed one time in 1,000 times movement, then we need to fix that. So that's very challenging for us because we need to make sure everything, and that's mobile robots. So the positioning is not that precise. Every time when it moves to a machine, the location will be different. So we have to come up with some ideas to be able to catch the component we want to catch and to move the component to the location we want it to move. So I think currently this part is very challenging for us.
Mm. All right, thank you. Yeah, so what's the requirement actually? They need, how accurate they need to be? The position accuracy you said for this this component, when you move it, how accurate you need it to be, position-wise?
Yeah, probably plus minus 5 millimeter. Okay,
I see.
so we have a fork that need to be placed under the component, and the difference, the location difference cannot be over 5 millimeter. So, but that thing is very heavy, so
Right.
it's not to carry a small items. So that's the challenging part.
Right, I see. Thank you.
You're welcome.
Okay, any questions from the student? Okay, yeah.
Hi, Professor. I would like to ask, how can smart manufacturing technologies be utilized in the provision of customized servers?
Customized servers.
Yes.
Like a customized production?
Yes.
Oh, okay. Actually, every single customer, our customers requires a customer system. Yeah. So for our customer, 80% may be common, but the other 20% is different. So every day we are dealing with those customization. Yeah. So actually, no two company have the same system. Yeah. Even the same company, when they build the first production line, when they want to build the second will be different from the first. So a lot of customization every day. Yeah. So that's also a headache problem for us.
I can also comment on that. I used to work in a traditional machinery company in Taiwan. All the customers has special requests.
Yeah.
They even ask, can you show me other customers' product? They want to take a look. Oh, this looks good. So they have no idea what they are looking for. They just want to see what other people are doing. They pick up the one they like and request some additional customization on top of that. So even they choose from existing design, they want to modify a little bit. So in the past, for every modification, engineers need to make drawings, save the data in a database, or keep the drawing in the storage. They have to build up several customized molds. But now, if we have smart manufacturing, we hope this kind of long process of customized design can be shortened. So that, I think that's the benefit of having digital technology being implemented in manufacturing. Okay, so thank you, Professor Chen. I think time is up.
Yeah, thank you, Professor Chen.
Oh, great. Thank you.
Thank you, and I will see you next time. And that's it for today. Thank you, guys. Bye-bye.